Am I audible? Am I audible, children?
Yes, ma'am.
Okay. So one thing. So there are 3 members in this meeting. So which chapter should I start? Should I start with electric current from the starting, or should I start with nutrition in plants, or what topic? Or should I start with acid bases? Yeah, Soumya.
Ma'am, nutrition and plants.
We'll start with nutrition and plants, Soumya. You want that?
Sure, ma'am.
Okay.
Ma'am, electric current and its effect.
Okay. Manas?
Ma'am, electric current only.
Electric current only for you also.
Yes, ma'am.
Okay. Soumya, I have a doubt. Like, why you asked nutrition in plants? Do you have any doubt in that chapter?
No, ma'am, it's just that my exams are gonna come up, so like I thought we were gonna like discuss it, but it's okay, ma'am.
Fine. Okay. We'll start with electric current then. Okay. Soumya, if you're feeling your exams are coming and you want to concentrate in that, then better you can, revise the slides. Will be helpful for you because you already know all the concepts in that. Just a revision is needed. That's all right.
Yes, ma'am.
Okay. So electric current and its effect. So what is an electric current? We all know that without current, life is impossible. Yeah. And Soumya, so are you okay? Soumya left the meeting. Okay, fine. So electric current. So current without electric current, the life is impossible, right? And because of electric current, various things are happening around us, right? Agreeing with me? How important is electric current? Electric current is important, so important that even without light, without fan, can you even imagine your life? Yeah. I need response. You can't, right? But have
Yes,
you
ma'am,
ever,
you can't.
yeah, but have we ever thought what is this electric current? What do you mean by this electric current? Who found it? Everything? No, we have no thoughts on that. But just we know that electric current is very important. Without current, we can't survive. That this is all there. But we have not thought what are the things is there beside this concept. What are the things we are no what is making up the electric current? What is electric current and all? Yes?
Yes, ma'am.
Fine. So, what are the learning objectives of this lesson? Understanding the flow of electric current, learning how to draw the circuit diagrams, understanding the difference between conventional current and electron flow. What is that? And we will see the different types of circuit based on the flow of electricity and connection of bulb in the circuit, distinguishing a cell and a battery. Okay, so these are the learning objectives of this chapter. And then understanding the effects of electric current and factors affecting the electric current. So, first, in the first part of the chapter, we'll be talking about what is an electric current, and the second part of the chapter will be talking about factors affecting the electric current. Yes,
Okay,
and then
ma'am.
we will apply these knowledge and we will find the components of electric circuits, and then we will understand the different types of circuits. What are the different types of circuits? As we solved today, we solved one question today, kind of series and parallel. So there are two kind of circuits, series and parallel. We'll talk about that. Yeah.
Okay.
Yes. Now, next, understanding the discrimination, doing the numerical problem. And then finally, of course, this is a part and parcel of this chapter, doing the electrical problems, sorry, numerical problems, the part and parcel of that. Yeah.
Yes, ma'am.
So I am telling you this chapter will be so there'll be two pathways. The pathway of this chapter will be like one pathway will be like you will be having a normal discussion that will be based on your NCRT book. And the second part you will be having deep down discussion that will be based on competitive exams, kind of JEE and KVPY, Olympiad kind of exams. So this chapter mainly goes into two different pathways. One is normal, one is deep. So obviously we'll concentrate in the deep. So as we discuss, I think we will be getting an idea what kind of problems we discussed today. Those are all JEE level, Olympiad level. So, or else it will be a normal NCRT level. It'll be basic questions will be there. You will be able to solve. That's all. Yes.
Okay, ma'am.
So anywhere, if you have any doubt, you can stop me any number of times and ask me what is that. Yeah.
Okay, ma'am.
Okay.
Okay, ma'am.
Listen this. See this video. Okay. 1 second. Just see this video, okay?
Innovative Kids presents. Innovative Kids presents the invention of light bulb. Thomas Edison inspirational story for kids.
Once upon a time, in a small town called Milan, Ohio, there lived a curious and determined young boy named Thomas Edison. From a very young age, Thomas was always fascinated by how things worked. He would spend hours taking apart gadgets and tinkering with machinery, much to the amusement of his family. One day, Thomas's teacher handed him a note to take home. Worried that it was about his constant experiments in the classroom, Thomas hesitantly handed it to his mother. To his surprise, the note contained a message from his teacher praising his curiosity and suggesting that he should explore his love for learning further. Encouraged by his teacher and supported by his parents, Thomas embarked on a lifelong journey of discovery and invention. He started reading books, conducting experiments, and even set up a small laboratory in the basement of his family's home. Thomas was always eager to learn new things and was never afraid to make mistakes. One of Thomas's most significant inventions came when he was working on finding a way to create a long-lasting and practical electric light source. For years, scientists and inventors had been trying to solve this problem, but no one had succeeded. However, Thomas was determined to change that. He experimented tirelessly, trying various materials and designs. Each attempt brought him closer to his goal, but he faced countless failures along the way. People often questioned his sanity, calling him a dreamer or a mad scientist, but Thomas remained undeterred. Finally, after thousands of attempts, Thomas found the perfect combination of materials for his electric light bulb. It was a momentous achievement that would change the world forever. With his invention, Thomas Edison had brought light to the darkness. But Thomas didn't stop there. He continued to innovate and create throughout his life. He improved the design of the phonograph, a device that could record and play back sound, revolutionizing the way people listened to music and audio recordings. Thomas's inventions weren't just limited to the field of electricity. He also developed a motion picture camera, which paved the way for the birth of the film industry. His inventions and innovations touched nearly every aspect of modern life, making him one of the most influential inventors in history. What made Thomas Edison truly special was his perseverance and resilience in the face of failure. He once said, "I have not failed. I've just found 10,000 ways that won't work." Thomas believed that every failure brought him closer to success and viewed setbacks as opportunities to learn and grow. His story teaches us that failure is not something to be afraid of, but rather a stepping stone to success. It reminds us that, with determination, hard work, and a passion for learning, we can achieve great things. So the next time you turn on a light bulb or listen to your favorite song, remember Thomas Edison and his unwavering spirit of innovation. He is an inspiration to us all, reminding us to dream big, think outside the box, and never give up on our ideas.
Got it? Got the video?
Yes, ma'am.
Yeah.
Yes, ma'am.
So this video is mainly talking about Thomas Alva Edison and his story, right? So in 1882, when it was sunset, so this miracle happened in the New York City. So he invented the bulb. So Thomas Alva Edison is the first man to invent the bulb. So this paved the way for, the growth of electricity, the enormous growth of electric current. So, and then it started with light, then fan, then other electrical appliances. So he gave a basement. He gave a big basement for, the development of electric current. Also, not electric current, development of electrical appliances. Yes, so it's important to note down that. And many countries began using electricity for domestic purpose. After that, electricity came. Many countries started using that. And 17 years after the New York in 1899, electricity first came to India. Then it finally came to India also. The first power plant was the Calcutta Electric Power Supply Corporation Limited. It was the first thermal plant in India on 1899. And then again around 1900s, thermal plant was set up in the Basin Bridge in Madras, and the power was distributed to government press, general hospital, electric trams everywhere. Yeah, nowadays everywhere we use electric current. It's not only just hospital or somewhere, everywhere in the household, community, everywhere we use the electric current. Yes. Now we are going to learn something called as atoms. So what are these atoms? So atoms are nothing but the smallest particle of anything, smallest particle in this whole world, you can say. All materials are made up of atom. We know that all materials are made up of atom. Do you know what is an atom?
No, ma'am.
Okay, so atom. So what is an atom? Atom is the smallest particle in the world. The center of the atom is called, and the atom structure is something like that. This is an hypothesis. This is not even microscopic. You cannot see atom in your naked eye or in the microscope. This is the random structure proposed by the scientist, or the most appropriate structure, you can say. Nobody can say like this is the exact way how the atom looks like. Okay. Atom. What's an atom? Atom is the smallest particle, and you have something called three things is there. Three kind of charges are present. So atom consists of a nucleus. So center of the atom is called nucleus, and the nucleus consists of protons and neutrons. Okay. And then protons are nothing but positively charged, and neutrons are nothing but neutral charged. Okay, neutral charge means no charge particles, and electrons are something that is going to revolve around the atom. Yes.
Ma'am.
Yeah.
So in the middle there is a few like those parts, right? So that is the real atom.
No, the full entire structure is atom. So you can
including
say,
electron only, it is the atom,
yeah,
right?
it is an atom. Yeah, including the electron, it is an atom.
Okay.
So if you see here, so atom, like normally you can do like this. This is a nucleus, and these are the orbitals. Electrons revolve around this, and this is a nucleus. Like you have positive, that is protons positive, and neutrons no charge. Yeah.
Yes.
Yes. So this is an atom. A normal hypothesis, like atom is like this. So what are the things atom has?
Nucleus.
Okay. Then
Proton,
neutrons,
uh, protons,
protons,
and electrons.
electrons. So inside the nucleus only you have neutrons and protons, right? Yes.
Yes, ma'am.
And protons are positively charged, and electrons are negatively charged, and neutrons are no charge, neutral, you can say. Yeah.
Electrons are the ones which are revolving around the
Revolving around. Yeah. Yes. Got it?
yes, ma'am.
Okay. Positive. Protons are positively charged, neutrons have no charge, negatively charged electron revolve around the nucleus in a circular orbit. Electricity is a form of energy that is associated with electric charges that exist inside the atom. So whatever the charges that we are talking about, protons and neutrons, electrons, not neutrons, protons and electrons, these are the electric charges. We can say them as a negative charge. Sorry, negative charges is electrons, positive charges is proton. We can tell them as a electric charges. Together we can say them as electric charges. Yes. Based on this electric charges only, we are having electricity. Okay. Now, this is an activity like I think you would have did this in when you're small. No? Comb your dry hair immediately after combing your hair. Bring the comb closer to the bits of the paper. What will you observe?
Ma'am, they like attract.
Yeah, the paper will be attracted, right?
Yes, ma'am.
So now coming to electric charges. What's an electric charge? Electric charge is a physical property of matter that causes it to experience a force, hence placed in electromagnetic field. So what do I mean by electromagnetic field?
Ma'am, electromagnet means usually when current is passed through a wire, the wire behaves like an electromagnet.
It behaves like a magnet basically. Yeah.
Yeah. Yes,
So
ma'am.
in general definition goes like this. So if I can create a magnetic field with the help of electricity, then I can say that as electromagnetic field, right?
Okay. Yes, ma'am.
If I can create a magnetic field with the help of electricity, I can say that is that as an electromagnetic field. Yeah,
Yes, ma'am.
remember this point. Now they're trying to say this. Positive and negative charges are the two type of charges. We know that, right? What are the positive charge and negative charge? Electrons and protons, nothing but, right?
Yes,
Protons
ma'am.
and electrons. Energy is created by the movement of the charges. So what they are trying to say. So I have an for example, this is a wire. This is a wire. Okay. Electricity is passing in that, and because of that, electromagnetic field will be created. For example, this electromagnetic field is created here, for example. Okay. So I
Okay.
have charges. I have charges kept here. Static charges. I'm just keeping charges. So if there is in the first case, there is no electromagnetic field is there. Just this wire is having no current. This normal wires. It means no force is given. Okay. Second case, I am starting to give the electric current in this wire so that electromagneticity will come. Electromagnetic field will be created. Yes. Once I create electromagnetic field, what will happen? These charges started to move from one place to another, from here to here. These charges will start slowly to move. Okay. And when these charges move from one place to the next end, from one end to next end, thus causing them electricity. Flow of charges. Flow of electric charges is nothing but electricity. Yes.
Ma'am, the charges means like,
Positive and negative charges.
so they are those protons and neutrons, right?
Neutrons. Yeah. Yeah. No, not neutrons. No neutrons. Electrons and protons.
Okay, ma'am.
Got it?
Yes. So the atom is there.
Atom is different. But we are here talking not about atom. Only positive charges and negative charges.
Okay, ma'am.
Yeah, not atom. Yes.
Yes.
So when there is no force applied, these charges will remain static. Static means not movement. There will be no movement. When I give some external force, then this charges starting to move, right?
Yes, ma'am.
That is the whole point. When there is a flow of electric charges, when the charges started to move, they form electricity. Yeah.
And that electric charges are caused to move because of that electromagnetism.
Magnetic force. Yes.
Okay, ma'am.
Every time it cannot be just it don't want to be just electromagnetic field. It can be some force that is driving these electric charges to move.
Okay, ma'am. Usually these charges are attracted to that magnetism, right?
Yeah.
Of the wire.
Yeah.
Okay, ma'am.
Yeah. Got it?
Yes, ma'am.
Okay. So that is all this para. This para is very important again. Electric charge is measured in a unit called coulomb. So you have unit for everything. What is the unit for measuring the distance?
Meter.
Meter. So what is the unit for measuring the weight?
Kilogram.
Kilograms, grams, milligrams. Yes. So like that, what is the unit for measuring the electric charge? It's coulomb. Yeah. It's coulomb, right?
Yes, ma'am.
So 1 unit of coulomb is the charge approximately. So we will say these many amount of protons or electrons is equal to 1 coulomb. Yeah. So
Yes,
we are
ma'am.
saying, right, 1 meter is equal to 100 centimeter. So 100 centimeter combines to form a meter, right? Like that, these many amount of charges, or like you can say protons or electrons, form 1 coulomb. Yeah,
Okay, ma'am.
got it? Got it?
Yes, ma'am.
Both of you? Manas
Yes.
also?
Yes, ma'am.
Okay. Fine. Electric charges are generally denoted by the Q. So we know kilograms are denoted by kgs, milligrams are denoted by mgs, right? And centimeters are denoted by cms or cm only. So millimeter is mm. So like that, meters. So like that you have symbols. For even for electric charges, you have symbol that is Q. Yeah.
Like that column, that is Q.
Q. Charges, not coulombs. Coulombs you can write just coulombs itself.
Okay.
Uh, denoted by charge. So every time I cannot say electric charge, right? I can
Yes.
simply denote them as Q. Yeah.
Okay.
Okay. Now definition of electricity. So already we spoke about this. So the flow of charges in a conductor is defined as electricity. Charges are transformed from one end of the terminal to other end. It is usually progresses from a positive to a negative terminal. The electron travel freely within the body since the nucleus hold them tightly. Just what is the definition of electric current is flow of charges from one terminal to other terminal. Yes.
Okay, ma'am.
Then it comes to power. Power is measured in unit called power. Sorry, units of power is watt. So you have something called power. Power is measured in watts. And who we named them in the honor of James Watt. Okay, he is the inventor of steam engine also. So then comes to voltage. So what is voltage? It's not over here. Voltage. I can tell you. Voltage is the force provided to electrons to push them through the conducting wire. So basically we saw electromagnetic force is the one who is going to create the flow, right? Because of that force, the electric charges are moving from one point to another point, right?
Yes, ma'am.
So I am just giving a term called voltage. So voltage is nothing but this is the force that is provided to electrons to push them through the conducting wire. While the current is at the rate at which electron flow. Yeah. Now listen to these two lines. Yeah.
Voltage, like, can you explain it again?
Yeah. Voltage is a force provided to electrons. I told you you have charges is there plus minus and all, right? So
Yeah.
voltage is nothing but the force I am providing to this electron so that they move from one point to another point in the
Okay, ma'am.
wire. Okay. Whereas what is a current? Current is rate at which electron flow. For example, there is a wire of length maybe some 5 centimeter. Current is flowing in this wire. At at this particular length of 5 centimeter, time for example 10 minutes will take. How many amount of current is flowing? Like can I find like that? So length of the wire is 5 centimeter. In this 5 centimeter wire, how many in 10 minutes? What is the amount of current flowing? That is nothing but the rate at which electron flow. What do you mean by rate? In given particular amount of time, how many charges are flowing, right? That's all. Given particular amount of time, how much charges? Because charges, when charges like plus minus charges flow, they make up the current, right?
Yes, ma'am.
So how many amount of charges flowing, and in how much time it is flowing, that is nothing but current, right?
Yes, ma'am.
In a particular given amount of time interval, maybe for 10 minutes, some 500 charges are flowing from this part to this part in the wire. So how will I find the current? I is equal to 500 charges is there. They are flowing from this part to this part of the wire in 10 minutes. That is T, Q by T. Yes. So can I represent the charges in Q that we saw in this before slide?
Yes, ma'am.
Charges are represented with the letter Q. So I'm just using Q by T. I is equal to Q by T. Yeah.
Ma'am, T means time.
Time. Yeah, time. Q means charges. Number of charges. Yes.
Yes, ma'am.
Got it?
Yes, ma'am.
Both of you? Both of you got?
Yes, ma'am.
Yes, ma'am.
Okay. The SI unit now comes to SI unit of electric current is amperes. Yes, electric current is ampere. Charge is coulomb. Don't confuse coulombs. SI unit of charges is coulombs, but SI unit of current is ampere. What is the charge? I is equal to Q by T. This is charge. SI unit of charge is coulomb. What is current? This is current. SI unit of current is ampere. Yeah,
Yes, ma'am.
got it?
Yes,
Yes,
ma'am.
ma'am.
You should not get confused between charges and the current. Yeah,
Okay, ma'am.
Okay.
okay. So these are the notations. So we spoke about like notations. So you have something called circuit diagrams. So what are circuit diagrams? We put the circuit diagrams, and we use the circuit diagrams to represent some certain things, and then we find the value of various things, current, voltage, resistance, and all. So for that, we need to know how to represent. For example, electric cell, that is a battery. Electric cell is represented like this. Electric cell is represented like this. So if I represent like this symbol, one is large, one is small, like this, then I can say this is an electric cell. Yeah, in the circuit. And bulb is represented using this symbol. And switch on, if the switch is on, then these two will be intact. It will be closed. Switch is off, this will be open. Yeah, this you can say this is open open. This is closed. Yeah.
Yes, ma'am.
And battery, what is a cell and what is a battery? So cell means only one terminal like this. So if it is a battery, means collection of cells, that's all. If I add 2 or 3 cells, then they make up batteries. Yeah, they make up battery. Yeah,
Yes, ma'am.
got it?
Yes, ma'am.
This is a cell, only one terminal is there. What is battery? 2 or more terminals like this, it's a battery. Yeah.
Okay, ma'am.
Okay, what is a wire? Wire is simply represented like this, a line, that's all. Yeah.
Okay, ma'am.
Okay, I think the notation is clear.
Yes, ma'am.
Okay. A battery, see here, a battery is a device that stores the chemical energy and converts into electrical energy. What is a battery? That stores chemical energy and converts it into an electrical energy. With the help of battery, they are giving charges to us, right? It consists of one or more cells. As I told you, one or more cells combine together to form battery. Okay, so what is actually happening? See this diagram. So this is a battery. There will be 3 things in a battery. One is cathode, one is anode, and one is electrolyte. So this is the chemical solution from which the electrons, are formed. Yeah. From this, the charges are formed. Yes. Got it?
Yes, ma'am.
Yes, ma'am.
Okay. So you have 3 things. One is anode, cathode, and electrolyte.
And
When the battery, yeah.
they are the chemicals which they are the chemicals, right?
Yeah, electrolyte is a chemical. Cathode is a node. I mean, like it's a terminal. Anode is a terminal. So you see this one more diagram will be there. See here, this is actually a battery. Yeah. So you have
Okay.
electrolytic solution. This is a chemical solution. And this is a cathode plate and an anode plate, and it is connected with the help of battery also. Yeah.
Yes, ma'am.
So this is a normal household battery that we use every day. So that is the diagram of this household battery. Yeah. One minute.
See how
Watch this video, okay?
what are batteries?
Are you hearing the sound?
Yes, ma'am.
What are batteries? Can you imagine a world where all electrical appliances had to be plugged in? Flashlights, cell phones, and toys would be tethered to electrical outlets, making them clumsy and inconvenient. Batteries provide portable, convenient sources of energy for powering devices without wires or cables. A dry cell is a common type of battery used today. It basically converts stored chemical energy into electrical energy. In the most basic terms, a battery cell is made up of three components: an anode, a cathode, and the electrolyte. In the dry cell, zinc is the anode, the graphite core is the cathode, and ammonium chloride paste acts as an electrolyte. Due to a chemical reaction within the battery, the anode builds up an excess of electrons. This causes an electrical difference between the anode and the cathode. The electrons want to rearrange themselves and displace the extra electrons in the cathode. However, the electrolyte ensures that the electrons cannot travel directly to the cathode. When the circuit is closed with the help of a conductive path between the anode and cathode, the electrons are able to travel to the cathode. This in turn provides power to any appliance placed along the way. Over time, this electrochemical process alters the chemical makeup in the anode and cathode, and eventually they stop providing electrons. And this is how a battery dies. Batteries provide us with a mobile source of power that makes many modern conveniences possible.
Got it? Got it?
Yes, ma'am.
That's how the battery works. Yeah. So battery is really very convenient source of energy, so that we don't want to plug in to, plug in every time. So that every time plugging in doesn't work. We need some mobile source of energy. So that way battery is very useful. Yes.
Yes, ma'am.
Yeah, so the batteries are used in tractors. So this Paheli and Bojo wonder whether the batteries used in tractors, trucks, and inverters are also made from cells. Then why it is called a battery? So can you help them find the answer to this question? We know that group of cells make up batteries, right?
Yes, ma'am.
That is the answer for this question actually. So read this passage. The batteries used in tractors, trucks, and inverters are indeed made from cells. Okay. However, these batteries consist of multiple cells connected together. Okay. So why they are called batteries? The term battery actually come from the Latin word batteria, means action of beating. It was initially used to describe a series of similar objects arranged in a line. So we know that series of similar cells arranged in a line make up a battery, right?
Yes, ma'am.
That is why they have named it as a batteria. It means series of similar objects arranged in a line. Series of similar objects in this area. Similar object is nothing but cells, right? Series of same cells arranged in a row to make up a battery. Yeah. In case of electrical batteries, the term was used to describe the series of electrical cells connected together. Over time, the term battery was stuck. Even then, modern batteries contain multiple cells. So when you hear the term battery, you think it is having a collection of cells. Yes?
Yes.
If wherever you say battery, it means they have collection of cells inside them. Okay?
Okay, ma'am.
Okay. Yes, battery and a cell are different concepts, but related concepts, as I told you. A cell is a single unit that generates electric current through chemical reaction. It consists of two materials called electrodes immersed in an electrolyte. When connected in a circuit, a cell provides electrical energy. What is a battery? Battery is a collection of cells connected together. It consists of two or more electrochemical cells with external connections for providing electrical devices. The cells within a battery work together to produce higher voltage and store more energy than a single cell alone. Yes?
Yes, ma'am.
And then that's all. This slide is describing about difference between a battery and a cell. That's all. Understood, both of you?
Yes, ma'am.
Okay. Then comes to
Yes, ma'am.
unit. Yeah. Then comes to unit of current. So unit of electric current. SI unit of electric current is ampere. We know that, which is the flow of electric charge across the surface, the rate of 1 coulomb per second. So I is equal to Q by T. Basically, we saw this definition, right? I is equal to Q by T.
Yes, ma'am.
Yes, ma'am.
That is what they are describing in this. So this is a piece of wire, zoomed up view of a wire, and you have a cross sectional area and charges. These can be positive or negative charges. Electric charges are traveling from one place to another place. This is nothing but the flow of current, right? This is the flow of charge. Flow of charge is nothing but current is flowing. Correct?
Yes, ma'am.
Yeah. So then we are going to start with the problems. So tomorrow, in tomorrow class, we will start with the problems. Okay, we'll start solving the problems. You
Okay,
have
ma'am.
a series of problems, and then we have circuits, and then we have resistors, and then we have a series and parallel, and then we will have questions on series parallel connections, some lot of questions, and then we'll go to Ohm's law. Okay, and then Ohm's law, and then we have some problems on Ohm's law, and then we'll go to heating effect. Yeah, so this is a big chapter indeed. Tomorrow we'll solve all these problems. Okay.
Okay, ma'am.
Okay.
Okay.
Ma'am, will get this video, this class recording?
Class recording will be already available in the YouTube, Manas.
Okay, ma'am.
Yeah.
It's not me, ma'am. It's her.